Hi friends, welcome back to my channel Simony. It's me Vaishak. Today we are going to discuss about relative velocity. So mainly we'll be focusing on trains in opposite motion, which is a one-dimensional problems. And in 2D cases, we'll be discussing river crossing, aeroplane in wind, and rain and umbrella problems. Good. Now before doing the examples, let us do the mathematical setup. Good. Suppose there's a train moving with a certain speed, let's say 3 meter per second with respect to ground. Good. So on the ground, there is a guy sitting, Jerome is sitting on a seat and observing that the train is moving with a 3 meter per second. And inside, there's a girl sitting, Leela, and observing that a child is moving with a zero point 0.5 meter per second. Good. Now, that speed is with respect to Leela. The question is, what will be the speed of the child with respect to Jerome, right? That will be just VJC. Remember, VJC is the speed of the child with respect to Jerome is equal to VTC plus VJT. VTC plus VJT. What is this? VJC equal to VTC plus VJT. VTC is nothing but the child speed with respect to the train or with respect to Leela, basically. Okay, and VJD is nothing but the train speed with respect to Jerome. That means with respect to ground. Got it? So basically, the Jerome measures the speed of the child as zero point 0.5 plus 3, which is 3.5 meter per second, which is 3 much greater than the speed measured by the Leela. That means Jerome measures the speed as 3.5 meter per second, but Leela measures the speed of the child as 0.5 meter per second. Now, why is the difference? Because there is a relative motion between the train and Jerome. Got it? Good. Now we can generalize this thing, and this generalization is known as Galilean transformation. Let's say there is a frame S dash moving with the speed v with respect to lab frame S. In S dash frame, if a person measures the velocity as u dash, then the velocity of the object measured by another person in S frame is given by u equal to u dash plus v, where u is the speed measured in S frame and u dash is the speed measured in S dash frame, and v is the relative velocity of the second frame with respect to the first frame. Okay. Good. Right. Now let's do a small example in one dimension. Basically, this is a train motion problem. The question is, two trains are moving in opposite directions in parallel tracks. If both have a speed of 60 km per hour and were initially separated by a distance of 1 kilometer, in how much time their engines will meet? Let's draw a small picture. This is a train, first train. Good. Let us draw the scenario. There are two trains. Let's draw the let's draw a simple picture for it. The first train is moving with 60 kilometer forward, 60 kilometer per hour forward, and second train is moving with the 60 kilometer per hour backward. We can call it as, you know we can consider that the first train T1 is moving towards east and second train T2 is moving towards west. with the speed 60 kilometer per hour. Okay, right. Now initial distance between them is nothing but 1 kilometer, correct? All right, now let's attach a frame on the ground. Suppose you are sitting on a bench and we can call it a slab frame. You're just observing it. Good. And you are sitting there and observing the case. Got it? Right. See, here the lab frame is S frame, and what is the S dash frame? You can choose either the first train T1 or second train T2 as the S dash frame. For convenience, let's take the first train frame is S dash frame. Okay, so basically we are right now measuring the speed of the train 2 in lab frame and in S dash frame. Okay, and in lab frame, definitely the speed is already denoted, right? This 60 kilometer per hour and 60 kilometer per hour is measured in lab frame only. Okay, now what about the S dash frame? We can consider the velocity of the train 2 with respect to T1 is u dash, u dash. Good. And the velocity of the T2 with respect to lab frame, that means S frame, is u. And u we already know, right? U is negative 60 kilometer per hour I cap, where I cap we are considering in the eastward direction. Okay, and u dash, we know the Galilean transformation, u equal to u dash plus v, where u is the speed measured in S frame, u dash is the speed measured in S dash frame, which we don't know, and v is the relative speed or relative velocity between S and S dash frame. Now clearly, velocity of the S dash frame measured in S frame is given by 60 kilometer per hour I cap, right? That is the first train velocity, correct? So clearly we can write u dash. Clearly from this equation we can write u dash is equals to u minus v vector, correct? U vector minus v vector, and u vector is negative 60 kilometer per hour I cap, and minus v is 60 kilometer per hour I cap. And that is clearly negative 120 kilometer per hour I cap. All good? Great. So the speed of T2 with respect to T1 is given by negative 120 kilometer per hour. That makes sense, right? Now, how much distance should be covered with this speed? 1 kilometer. So let's find out the time. The time required will be whatever the distance covered divided by the speed, right? So the distance is given by 1 kilometer and the relative speed is given by negative 120. So let's consider the magnitude only, right? So 120 kilometer per hour. So basically 1 divided by 120 hour, which will be 0.233 hour. Got it? That will be the answer. Right. Now question number 3. An aeroplane needs to go from Colombo to Chennai, which are in the same longitude. If speed of aeroplane is 72 km per hour and there is a crosswind with a speed of 180 km per hour from east to west, at what angle with respect to the longitude the aeroplane directed? And second part is, if distance between the two cities is 650 km, what is the flight time? Interesting question, right? And this is very application level question, because this is what the pilots will do, to reach from, to travel from one point to another point. The pilot has to adjust their nose so that you know they will overcome the wind speed and reach the destination. Okay, good. So let's answer it. So of course we had to answer by drawing a diagram, right? So same longitude means same they fall in the vertical line. All good. So basically, whatever the velocity of the aeroplane with respect to wind and the wind velocity together must give you the resultant velocity, right? So let me draw the individual velocity vectors, then you will understand more. This is the velocity of the aeroplane with respect to air. This is the velocity of the aeroplane with respect to air. So P denote plane, aeroplane, right? So, and next velocity is the velocity of the air, which is directed towards east, right? So let me denote it as velocity of the air with respect to ground, right? Remember here, air is S dash frame and ground is S frame, right? That's very, very important. And resultant vector must be like this. What is that actually? This is the velocity of the aeroplane with respect to ground. And let me draw overwrite arrow for VAG. Right. Now clearly what we had to find is the angle theta, right? Basically angle subtended by the aeroplane with respect to the imaginary line connecting A and B, or in other words longitude, right? Good. In the first part of the question we had to find the angle theta, right? Now to avoid confusion, let me write everything, every vector names. So VAG is nothing but velocity of air with respect to ground. VPA is velocity of aeroplane with respect to air. Okay, and what is this VPG? VPG is nothing but velocity of aeroplane with respect to ground, which we don't know. Okay, right. Now how we can find the theta? We can use again sine theta. Sine theta is VAG divided by VPA. VAG is 180 and VPA is 720. All right, which is nothing but 1 divided by 4. So theta equal to sine inverse 1 by 4. This is equal to 14.47 degree, right? Good. We are in the second part, we are provided with the distance between A and B, right? Starting point and ending point. So what is the flight time? Remember, the flight time only depend upon the y component of the velocity, right? So what is the velocity in the y direction? VPG clearly, right? So VPG equal to whatever the distance between A and B, which we can write y divided by time. Therefore, time is equals to y divided by VPG. Now, how to find the VPG? We can use Pythagorean theorem and write VPG square is equal to VPA square minus VAG square, right? So VPG equal to square root of VPA square minus VAG square, which is nothing but square root of VPA square is 720 square minus 180 square, correct? So this is given as 697, right? Therefore we can find the t equal to what are the y distance, which is 650 in the question, right? 650 kilometer divided by 697 kilometer per hour, and therefore which is equal to 0.93 hour, right? That is the answer. Now let's focus on question number 4. Imagine you are walking straight down the street at a speed of 1 meter per second in the rain. The raindrops are falling vertically with a speed of 5 meter per second. At what angle should you tilt your umbrella with respect to the vertical to effectively block the rain? Good. Right. Now let's answer it. See, to understand this, we have to denote what is the S frame, what is the S dash frame, right? That is the first step. So let me denote. S frame is definitely, S frame is nothing but ground. S dash frame is, of course, the person itself. This is because the person will feel the rain differently compared to another person who is at rest with respect to ground. Okay, right. And let me draw a picture to show you the actual direction of the raindrops. Okay, right. Let's draw the direction of raindrops with respect to ground. So this is nothing but the velocity of raindrop with respect to ground. Let me write like VRG. So VRG is velocity of raindrops with respect to the ground, or S frame. Okay, right. Now the person is walking forward, let's say towards the east direction. Now we can denote that vector as VPG. Good. So let me draw that VPG. So VPG is velocity of the person with respect to the ground. All good. Now the person is the S dash frame, right? So for the person, the velocity will be different because there is a relative motion between the ground and the person, right? You know, the relative velocity here is nothing but VPG, right? So basically the person is a dash frame and that frame is moving with the VPG speed, right? Good. Now the person or the S dash frame will measure the speed of the raindrop, and we can call that measured velocity of the raindrop as VRP. Okay, so VRP, let me write here velocity of raindrops measured by the person is VRP is equal to VRG plus VPG. This is nothing but Galilean transformation. Now we can use the idea of scalar addition, right? If you remember the tail to tail method, we can deploy for addition, correct? So the resultant vector will be a vector from the tail of the first vector to the head of the second vector. So this red vector will be the VRP. All right. Now this is the velocity felt by the person. So what the person has to do, with the umbrella has to be tilted in the same direction of that measured velocity. All good. So the tilting angle is definitely, we can denote with an angle theta. Let me write here angle theta. Now that is interestingly, this is the same angle as this, right? Opposite angles. So I can denote the theta like this also. And in the triangle ABC, I can write theta as tan theta equal to opposite side BC divided by adjacent side AB, which is, what is BC? BC is nothing but the VPG, right? The person is walking with 1 meter per second speed, so we can write 1. And the raindrop, the velocity of the raindrop with respect to the ground is 5 meter per second, so 1 divided by 5. This implies that theta equal to tan inverse 1 divided by 5, which is equal to approximately 11.3. So the person has to tilt the umbrella at an angle 11.3 degree with respect to vertical. Is it forward direction or backward direction? Of course, if you look at the diagram, it is backward direction. So he has to, turn his umbrella or tilt his umbrella a little bit backward with an angle 11.3 degree. Good. Right. Now let's focus on the question number 5. You are standing on a rainy day and the raindrops are falling vertically with speed 25 km per hour. Suddenly a wind blows towards west with a speed of 15 km per hour. At what angle with respect to the vertical should you tilt your umbrella to block the rain? So the question is very similar to question number 4. However, the person is still at rest. That means the person itself is the S dash frame right now. Previously the person was S dash frame. Now the person is S frame because person is still with respect to the ground. Okay. So we can say either the ground as S or the person is S because there is no relative motion between the ground and the person. Right? So let me denote it here. S frame is the person itself. S dash frame, just think about it. What will be the S dash frame here? S dash frame is nothing but air itself. Okay, because with respect to air, the speed is 25 km per hour, but the air itself is moving because of the wind. So with respect to ground, the speed will be different, the velocity will be different, right? Good. Now let us draw a diagram. See, with respect to the air, the velocity of the raindrop look like this, so we can call it as VRA. Let me write here, VRA is nothing but velocity of raindrops with respect to the air. All good. Now the air itself is moving, all right, in which direction? Towards west direction, right? So let's denote that with a vector here towards west. We can denote with V air with respect to the person, VAP. All good. So VAP is velocity of air with respect to the person. Right? Now let's call the velocity measured by the person as let's denote the velocity of the raindrop with respect to the person as VRP. Okay, so velocity of the raindrops with respect to the person, I can call it as V or P. This must be equal to VAP or VRA. This must be equal to VRA plus VAP. Again, the Galilean transformation. Okay, right. So, of course, we had to use again head to tail method. Let me draw the vector or the velocity measured by the person. Good. So VRP here. Now what angle we had to find? See, it is the angle of the umbrella or tilting angle of the umbrella. So that angle will be with respect to vertical will be nothing but theta here. That theta will be the theta here also, right? Since this is theta, this also must be theta, the opposite angles, right? So let me denote this angle as theta. Now clearly theta is tan inverse VAP divided by VRA, opposite side divided by hypotenuse. So it is tan inverse VAP is in the question 15, right? So 15 divided by velocity of the rain with respect to air is 25. So 25. Good. That is tan inverse 3 divided by 5. Good. This is equal to 30.96 degree. So the person has to tilt the umbrella at an angle 30.96 with respect to the vertical. All good? Right. So that's it, folks. I think that's good for today, and we shall meet soon with a session on Newton's laws. So do the maximum problems attached as a link below. So stay tuned. See you. Have a great day. Bye bye.